This next video, I want to talk about normal force. Normal force. It's a term that you'll hear quite often in physics, and it's a really important concept to understand when we're talking about net forces. So here's how it goes. We're just going to start off by talking about, let's see here, a person that's standing on the ground. Now I'm going to give this person a mass. I'm going to say this person has a mass of 70 kilograms. What I can do is I can actually figure out how much this person weighs, and I can write that as a force down here. So I'm going to draw an arrow down here representing their weight. Right? We can actually solve to figure out what their weight is. Remember, W weight is m times g. And if I use 10 meters per second squared for g, just makes things easier. So I can say their weight is 700 newtons. Well, we've got a little bit of an issue here, because what I can now do is I can start to look at, well, let's see what Newton's second law says. Newton's second law says that acceleration is force divided by mass. And I could actually calculate for this problem, what the acceleration would be. I've got a force of 700 newtons divided by a mass of 70 kilograms. So what I should end up with is an acceleration of 10 meters per second squared. Well, that's kind of an issue, because this person is standing on the ground, and clearly they're not accelerating at 10 meters per second squared. So we're missing something here. And what we're missing is that I forgot in this equation here to write in this spot right there that this actually needs to be net force. Right? So this is a net force. So let's see, how can I write that in there? I'll just write net force inside there. So the net force in here is going to be different than the 700 newtons. So this is not right. This is not right. We can't actually do that. What I'm missing is another force that's acting on this person. There's got to be something that's balancing it out, because quite clearly this person is not accelerating. So let's see, just scooch this up just a little bit so we can stay in it. Okay, so really what we know is that the net force has got to be 0. How do I know that? Because if I write this, acceleration is F net divided by m. I know that for this particular situation right here with a person standing on the ground, their acceleration is 0. So that must mean that their net force has to be 0 as well, because they're not accelerating. They're standing on the ground. So I'm missing a force. And the force is actually from the ground pushing up on the person. So we can draw that in here. And now I'm going to actually draw it up here. Even though the force is acting on the ground down here at their feet, I'm going to draw the arrow up here, up higher, so that I can actually see what's happening. And what I'm going to label this is F normal. And a normal force doesn't mean like normal as far as strange. Normal means perpendicular. It's another way of saying perpendicular. What is it perpendicular to? Well, the normal force is perpendicular to the surface. There's the surface, and the normal force is perpendicular to that surface. Right? So that's how that works. That's the normal force. Now we know what the actual number is for the normal force. I know that the normal force here has to be 700 newtons. Why? Because I know that my net force has to be 0. If I come down here, I know that my net force has to be 0. So we can say net force, and I can say it's going to be the weight plus the normal force. Now you might go, wait a minute, whoa, you can't do that, because that's 700 newtons plus 700 newtons, and that's going to give me 1400 newtons, not 0. Right, we have to remember that these are vectors. We're adding them up like vectors. So this plus right there really needs to account for the fact that one of them is going in the opposite direction, right? So this one is going, oops, that one's going up, and then this one's going down. So what I need to do is I need to account for one of them going up and one of them going down. So instead of a plus 700 newtons down there, what I need to do is I need to I'll make the weight a negative since it's going down. We like things that are going down as negative. So that's going negative right there. That's not 1400 anymore. That's 0 newtons. So that's a quick little introduction to normal force. Once again, a normal force means perpendicular to a surface, right? Anything that's sitting on a surface is going to have a normal force acting